Okay, so if we are trying to solve the entry problem of doom today, we have two numbers that are given to us. 2184, and that one's going to be kind of in a maroony color when I'm solving today. And then we also have 203, and we're supposed to be finding their prime factorizations, and then we can use the prime factorization to then identify their greatest common factor and their least common multiple. And this was a skill that we struggled with a little bit on our most recent math quiz. This is a good thing for us to be reviewing. So when we're given two values and we need to find their prime factorization, you guys know how much I love my factor trees. So we're going to work on that first. And remember, the first thing we do is just pull out the smallest prime factor that we can. So we know that this number is divisible by 2 because it ends in a 4. So 2 is going to go over here. And then 2,184 divided by 2 should be 1,092. Again, that last digit is even, so we know that another group of 2 can be pulled out, and we should have 546 left. Hopefully this is all correct. Another group of 2 can come out because we got a 6 at the last digit, and then 273 should be remaining. Now, sometimes when I see numbers like this, I think, that could be prime. But we know what the rule is for identifying what factors can be found for each of these values. So we know it's not divisible by 2, and therefore it's not divisible by 4 or 6 or 8. But if we add all of the digits together, 2 plus 7 is 9, plus 3 is 12. If that value is divisible by 3, then the whole number is divisible by 3. And indeed, 12 is divisible by 3. So 273 divided by 3 should leave us with 91. And then 91 is divisible by 7 and 13. Kind of a yucky set of numbers to be dividing, but there you go. All right, so our prime factorization for 2184, we can write all out. 2184 equals, and then we just do it in order from least to greatest of the common factors, or of the prime factors. 2 times 2 times 2 times 3 times 7 times 13, and that's the prime factorization for 2184. Now we have 203, not divisible by 2. And it's not divisible by 3 either, because 2 plus 0 plus 3 is 5, and that's not divisible by 3. But it is divisible by 7. And if you divide 203 by 7, you have 29 as a remainder. And 29 is prime. So boom, prime factorization, easy peasy right there, 203. So if we focus first on greatest common factor, I'm actually going to copy and paste this guy so I don't have to rewrite it out. So we're going to copy this. And then I'm going to paste another one over here. Okay, we'll leave that guy there for now. For greatest common factor, all we do is we circle the groups of shared factors between the numbers. And sadly for this one, it's a little bit boring. All I see here is 1, 7 in each number. So the way we would write the final equation here would be GCF, and then I just do in parentheses any numbers that are in the sequence. And it's 7, lonely 7, a little bit sad. But you guys know when we get to least common multiple, I'm gonna move this guy over. I don't think I can move it now that's over here. Well, you guys can see all the work that I did yesterday. When we do least common multiple, we're not killing the shared numbers, we're killing the spares. And so this is our little Harry Potter link here, but we circle our first 2. There's no 2s for us to kill in 203, so we just leave it. Circle this 2, this 2. Circle this 3, there's no 3s for us to kill. But we get to this 7, boom, we can kill the first 7 in 203. Circle this 13, and then 29 is our last guy. So the LCM, I'll write it down here, of 2184 and 203 equals the product of all of the circled factors. And actually, I haven't solved this. So it's going to be 2184 times 29. So let's see, 2184 times 29. 9 times 4 is 36. 9 times 8 is 72, plus 3 is 75. 16 and 19. All right, 8, 16, 2, 3, and 4. Please let this be correct. Okay, is this real? This is a real number? 63,336. Well, my friends, that is indeed how we use greatest common factor, or use prime factorization to find the greatest common factor and the least common multiple.